All right, well, it's about that time. Last presentation of the day, and I promise I will not keep you from happy hour too long. So what we're here to talk about today is plugin development in a collaborative fashion. So I'm Joe Cavanagh. I work on Spinnaker at Apple. I'm here with my colleague, Ben Powell, and I'll pass it over to him to get us started.
Cool. Thanks, Joe. So today we'll be talking about plugins within Spinnaker, starting with what they are, the security implications, why develop them, and the internal plugin platform, how to build and operate within that platform, and lastly, what can be improved. Plugins can have many definitions. Sometimes those definitions can contain the word plug, which is a little ambiguous, but I think we can do better. So what exactly is a Spinnaker plugin? Well, they are bundles of new code that add features and functionality to Spinnaker. They can be created for both the UI and the backend, like creating a new stage, for example, and can have any kind of configuration that they need. The technical basis of the plugin system is the Spinnaker extension point interface, which defines which components of Spinnaker are intended to be extendable. So in the example that we have here, we have a sample stage. This implements the stage definition builder. This builder is used to build new stages within Spinnaker. This interface also implements the Spinnaker extension point interface, which allows for plugins to have the entry point that they need. Further, plugins can provide Orca tasks and stages, atomic operations, and pipeline expressions, and many more. Plugins can also provide any new implementation of a Spinnaker extension component and can ship with any dependencies that they need. In addition to being able to ship with any dependencies that they need, they can also inject any application Spring Bean within to themselves, just like how internal components can. This makes plugins very powerful, but also a dangerous concept inside of the system. So before we go any further, I would like to highlight some points about the current power of the plugin system. Plugins have access to any Spring Bean and are not sandboxed in any way. So this means that you basically can do anything. So this is both good and bad, right? So with that, any plugin you operate within Spinnaker should be considered completely privileged. Malicious plugins can be very destructive or even leak secrets. For example, if a plugin author decides to use the Kubernetes credential provider, that plugin would have access to all Kubernetes accounts that plugin has access to, or that Spinnaker has access to, sorry. It's very important to keep this in mind that plugins have access to all Spinnaker components, meaning they also have access to all external systems that Spinnaker has access to. This makes the possibilities of maliciousness nearly unbounded. If you're going to run contributed plugins, it's very important to have this in your threat model. So, however, internal platforms are generally safer. Internal contributors are generally not out to cause harm, but there is always the risk of unintentional misbehavior and always the slight risk of a malicious internal actor. These things are very rare, but they do happen. This really highlights the importance of review, testing, and vetting. Understanding what you are running is key to success. It has often been said that small problems have small solutions. And I think that's very true. We as engineers often just live with small problems because they're either too hard to fix or other priorities come up. Adding functionality to the main Spinnaker is not a trivial task. It's a lot of work. So that can mean sometimes that you have to now commit to a very long-term maintenance commitment there. So the small scope of a plugin also allows for less technical people to effectively contribute. A few samples of plugins can get someone very far. I myself am not an expert in every tool that Spinnaker might talk to, and general CI/CD teams within orgs oftentimes don't have the bandwidth to support everything in a corporate ecosystem. So we do have a lot of technical users, though, that will be very happy to build things that they need. And utilizing those talents is good for everyone. Plugin use cases are often very similar in that making a new stage has the same basic structure no matter what that stage is doing. So creating samples, documentation, or library classes for your plugin authors can dramatically speed up their work and focus their efforts down the correct path. As the plugin system grows, opportunities to extract shared code will naturally present themselves. A little bit of curation here can go a long way in having a cleaner and more reusable plugin code base. Now, to expand on the internal plugin platform, here's Joe.
Oh, thank you, Ben. So one of the main things we're working on internally is having a plugin platform that's making Spinnaker a target for that engineering teams can reasonably develop for. Then within the context of an organization, there are dozens, hundreds of tools and services that people use to deliver whatever it is that they create. Spinnaker probably supports many of them out of the box, but there's always gaps. This is especially true if you need internal-only features, which are either irrelevant to or must be hidden from the outside world. In this case, you have little choice but to own a fully fledged fork of Spinnaker, and you'll have to build quite a lot of things to manage that on top of the feature you actually wanted. Obviously, there are a lot of organizations that cannot or do not wish to take on such a huge burden, and this drives them to seek other tools. Instead, if we can reduce the scope of work to a small, self-contained plugin, the value proposition is suddenly much more attractive, and extending Spinnaker becomes a much more viable option than building bespoke tooling. Teams that need specific features from Spinnaker essentially have two choices: implement it themselves or find someone else to write it. In the latter case, they might be waiting forever. Teams don't want to wait forever, so they're going to end up doing their own thing. Plugins provide a way for them to help themselves while still having a relatively small scope of work. This is much more palatable to your average project manager, and it's much more likely that it'll actually get done. But let's not forget that it's always hardest to go from 0 to 1. The first plugin anybody writes is always going to be the most difficult. So what we can do is build a plugin platform that takes away everything that isn't plugin development and makes it as easy as possible for otherwise technical users to contribute to Spinnaker. We can provide a baseline process for every plugin. Build and test are standardized, plugin publishing is fully automated, and plugin authors can focus on authoring plugins instead of having to understand every part of the operational process. So I'm sure we all love golden paths here, so why not a golden path for extending your own tools? And so these are the components that one would need to provide a reasonable basis for extending Spinnaker, and we'll go through some of them now. Number one, we need to make our code reusable. One of the major problems with Spinnaker plugins is they tend to exist in their own little islands. These islands can get quite stale if they're not actively maintained, and let's be honest, a small plugin repo is not the kind of thing that often gets active maintenance. And once you have more than a few, it becomes necessary to have the ability to quickly update and share code among many projects at once. The most obvious way is to just extract and publish some libraries. Very straightforward, gets the job done. Engineers have been doing that for decades. However, I hate bumping versions, and I hate making robots to bump versions for me. So the approach we've elected to take involves a single multi-tenant repository for all plugins using Gradle composite builds to handle shared code and libraries. If you're not familiar with Gradle composite builds, it's pretty simple. You can add other co-located Gradle projects right at the root of your repo tree as included builds, as Gradle calls them, and then they'll just build and use that code directly from the source tree right there in your repo. It achieves this through some dependency rewriting magic within Gradle itself. So if, in the example of a Java project, it'll match on the group and the second part, and It'll rewrite it and use the source code it just built from right adjacent to the thing. So this has a number of advantages. Anytime you make a change to shared code, you get immediate compiler feedback from every other plugin. This makes refactoring very safe, and you can very quickly extract reusable code from existing plugins. This is a lot faster than finding out something broke in a version bump PR, than having to go back and investigate and then do the whole commit, review, publish cycle again. That sucks an incredible amount of time. The second major item is making use of code your organization already has. Every company writes code for themselves and has libraries or CLIs or whatever it is to talk to internal and external services. If Spinnaker can use those same components that you already have to connect to those services, it'll be a much more useful and powerful tool in your organization. Now, obviously, your internal libraries cannot and should not be a dependency of the main open source project. So plugins provide an ideal way to reuse all of that. If it runs on the JVM, you can use it in Spinnaker. And there's a lot of companies who write stuff for the JVM. So this is greatly preferable in general to owning and maintaining a fork, and you'll still be able to do everything you need to do. But perhaps the most important part of a plugin platform is build and test. Plugin compatibility is always going to be the #1 problem to solve. Fortunately, plugins have very similar build and test needs, so it makes perfect sense to unify the process. Level 1 is basic Spinnaker version compatibility testing. Build the plugin against one or more versions of Spinnaker libraries and see if it compiles. Plugins do need to be able to specify their compatibility targets, since breaking API changes from the Spinnaker side do occur, but you'll have confidence that they will run within those targets. It's also possible to do full startup compatibility testing in CI. If you're familiar with the main project's code base, you'll see some startup Spring Boot tests that live there in the code base, which essentially starts Orca, starts Cloud Driver, and just make sure the Spring situation is sane and everything is getting wired up and the app will actually start. So same thing's possible here. You just give it a plugin, have it load that as well as the main app, and then see if it starts. So that'll get you at least across the line to it's not from it's existing here in the repo to it's not completely broken, which is a great step 1 to have. If you have test instances of Spinnaker, you can also test by running real pipelines using plugin provided components. Set up some test pipelines and run them any way you wish on the plugins that you've configured in your test instance. And based on the complexity and the criticality of the plugin, you can choose the level of testing that's right for you. Not everything needs the full test experience, but it should be there if it's needed. Plugin publishing is the penultimate step in the process and is the most operationally focused of all the various steps. And the procedure for publishing and retrieving plugin bundles is going to vary almost entirely based on your infrastructure, where you store files, what things you use, what your source control product of choice is. It's all going to change with all of that. But you need somewhere to store them. So these plugin bundles, they're zip files. They have metadata that comes along as JSON. They need to be stored somewhere. Anywhere that can store stuff and serve files over HTTPS, good to go. So, and again, within the storage, we have the bundles and the index. The index is a JSON file in the format you see here. It has each plugin with its ID and a list of releases, essentially. And something needs to regenerate this file whenever you make a new plugin. So this is ideally another fully automated part of the process and should be part of your CI tooling. This part is, in my experience, very confusing to plugin authors since they're not at all concerned with the operation of Spinnaker. They don't know how it works. They don't know how it runs. They don't have to know. So it's definitely best to abstract this part away. So Helm is a good parallel to this kind of design. Helm has a similar root level index YAML file, which just lists everything that's there. But humans don't read that unless something's broken. That's read by other tools. Same concept applies here. And now once you've written, built, and published your plugin, it's now time to run it somewhere. Plugins can, unfortunately, cause an operational burden, so it's important to have a collaborative relationship with whoever operates your Spinnaker. This is also true the other way. Operators should have collaborative relationships with plugin authors. There's going to be problems, and mutual respect and resolving problems in a constructive way is going to be the best way to do that. If you do happen to operate your own Spinnaker, you're done. Congratulations. Configure your plugin however you configure anything else and run it however you'd like. But if someone else operates your Spinnaker, then you must be ready to work with them if there are issues. As mentioned before, a robust build and test process will catch the vast majority of issues well ahead of this point, but inevitably something will explode. And this is normal. Plugin authors are not always Spinnaker wizards. You're not going to get like the world's most excellent code in there all the time because, you know, they're looking for something that solves their use case and is good enough. They're not always professional engineers. They're just technical people who want to contribute, and they should be able to. So, but this will require a little bit of patience from the operational side on rare occasions. So, but at this point, the proper course of action is just to collaborate. If the plugin's very important, super critical, you know, maybe have a line of communication always open. Otherwise, the fact that it's all in one place makes it very easy for anyone to go in and fix it. So for example, if there's a new Spinnaker release and it breaks every plugin, I have the ability to go in and fix everything myself, for example, should that be necessary. I don't have to track down 27,000 plugin authors and be like, hey, well, you got to change this thing to this other thing. No, I just go in and do it to everything. And bam, everything's republished, everything's done. But along the way, we did find some items that would be good candidates for refinement. The most critical is safety and stability. Plugins are very, very powerful, but that power magnifies the risk tremendously. As mentioned before, plugins have access to absolutely everything within Spinnaker. It might be useful to control what Spring resources and beans a plugin can use and, you know, mitigate some of the plugin risk that way. But plugins that fail Spring auto-wiring will also fail the entire service because it's all part of the main Spring context in the end. Plugins and their classes, they all get promoted and slurped up into the main Spring pile of Spring stuff. And if it doesn't come together correctly, Spring's just going to fall over and be sad. So we don't want Spring to fall over and be sad. We want it to be running and relatively happy. So the nuts and bolts of the Spinnaker code base can also be a little bit problematic for extensibility. So the most obvious way to write Spring in general is to have configuration classes with factory methods that make some beans and do that. And Spring will collect and provide all their various dependencies. You know, that's kind of the point of Spring. But plugins aren't yet loaded when most of these configuration classes, constructors, and factory methods are called. So they won't see those plugin providing components. So if you have a factory method that takes a list of some object, and one of those is meant to be provided by a plugin, you're not going to get the plugin one because it doesn't exist yet. So what you have to do is build the code to consume plugins. So Spring has ways to dynamically provide beans of a certain type, notably the object provider construct within Spring. And lots of classes within Spinnaker have already been updated to use object provider to fetch beans dynamically. So when plugins contribute new classes to the Spring context, the code that uses them can pick them up and consume them immediately. So code that is intended to be extensible always needs some way to dynamically update which Spring beans it knows about as plugin provided components get put into the application during startup. So we can avoid this by keeping extensibility top of mind when doing new development. If a feature can be reasonably augmented by plugins, it should be a Spinnaker extension point from day one, and it should also be capable of consuming plugin provided components dynamically. So the more stuff that works with plugins out of the box, the better plugins are going to be. So I have a bit of a demo for you as to what such a thing might look like if it were running on public GitHub. So we'll swap to our delightful mirror mode here. It's a little dark, but I think we can hopefully see. All right, so here's the various components. What we have here is a set of default configuration that is intended to run Spinnaker basically out of this folder. And I'll get to that in a minute. So this is a bit of build plugin code that helps with all these various tasks. This is a Postgres initialization, which will init the Postgres DB, which lives on a Docker volume. We have a common library. This is just a regular Java library that provides some Java code to our sample plugin A and sample plugin B. These plugins don't actually really do anything. They're just here to show, take up some space and make some GitHub releases. And then we have a template to use to generate a new plugin based on whichever services you'd like to extend. So as far as Gradle composite builds, the way that's set up is here in settings.gradle. This is a standard Gradle feature now. So we're including our plugin that are used throughout the application to provide build helpers. We have our common Java library. We have plugin A and we have plugin B. So, and anytime you get a reference to this common code package, Gradle will again go find it in this repo because we've told it where it is, and it will build this, and it will use that in whatever dependency. So plugin A and plugin B sample both use this, and that gets built every time they get built, and that's the essence of a composite build. There's also a Docker Compose setup here, which has all of the Spinnaker public container releases here. You can choose any release or the release from master. So what I have running is if you can see this right here, so this is Docker PS. This is running a variety of Spinnaker master images. We live on the edge over here. So what's also included is a Postgres and a Redis. And included in that default configuration I mentioned before is Postgres and Redis already set up for Spinnaker to use for local development. And that's how this is intended to be used. You have a local Spinnaker, it runs in Compose. You publish plugins to configure it. That config gets mounted to each container. And then all you have to do to load your plugin is restart Orca or Cloud Driver, whichever service the plugin is for. If it's deck, you just reload the page. So that part is pretty painless. So I have a few pull requests here to show what some common things might look like. So for example, here in my common code library, I've broken it. Oh no. So what have I done? Egads, I've inverted the logic. Well, good thing I wrote a test that would check to see if I'd inverted the logic, and it failed. So thank you, Mr. Pull Request. So you can see that the other plugin builds did succeed because the API didn't change. The functionality of the code was just broken. So but the process has told me, aha, your common code is broken, you'd better fix it. And the same goes the other way. So if I make an API change to shared code, I get instant feedback from every other plugin that uses that library. So here's my sample common code. It's nice and happy. The test passed. But I changed the name of a function. So instead of is blank, I've named it is this string blank, because I've heard that being explicit is a good thing. So we're going to change all my function names to be more explicit. Unfortunately, that broke everything. And luckily for me, the CI across all of my plugins at the same time told me that I just broke every plugin, and I should probably reconsider that change, probably. And over here, we have, I'll give you an example of what a release management looks like. So here, I'm bumping the version of sample plugin A. And this looks good. Yep, that's definitely a version. So we'll just merge that in there. And then we'll head over to our GitHub Actions page and run the publish job for sample plugin A. And while that's running, I'll go through the fact that this is also a fully fledged plugin repository that updates its list of plugins every time you publish anything. So that plugins.json file that you saw in the presentation right before, that's also right here. This is automatically generated by the build tooling and automatically updated every time that a new release happens. And it just auto-commits it right back to the repo. And so everything in here is every release that's been made from this repo gets stored in this case, GitHub releases. If I click this link, you can see it will give me a nice happy zip file. And there it is. And there we go. This is just a fully automated plugin development. Press the button. Now it's released. It's in your plugin index. You go tell Spinnaker that, hey, I want to run 1.01 instead of 1.0 now. And that's it. That's your entire development flow. We'll see if this has finished yet. It hasn't. Come on, I believe in you. Go GitHub. GitHub's trying its best. In the meantime, I actually have all of this running locally on my machine as well. So this is all those containers you mentioned. We're starting from that Docker Compose file. And if I look in this pipeline, I can see that my sample plugin A is present here. And I can, I've already added a couple. The plugins have configuration. The point of the plugin is to output this string into the UI, which is, of course, a very important job. And so here I've told it what to do, and here I've told it nothing at all. So let's just go see what happens when yes, I'd like to delete all the changes. All right, is it going to work? Let's find out. Oh, here we go. Come on, little button. Oh, hold on. Sometimes it goes to sleep. Oh, it did. There we go. That's it. That's the one. Yeah, sometimes the UI gets sleepy after the laptop's been closed for a while. So wonderful. It's output my string here. It says I'm a string, and it sure is. But this one, this is a string from the sample plugin HTA content. Well, where did this come from? Well, this is a configuration default that I put in my sample plugin. So plugins have configuration, as we mentioned. And I've written in its default config that this is the string that it should use whenever it doesn't have a string, and there it is. So there we go. It's if I wanted to make a change, I can just, as I mentioned, change the code, rebuild the plugin, restart Orca in this case, and I'll be iterating very quickly. So this is the sort of intended model that we want other people to get on board with internally and extending Spinnaker, because this is, as we see it, our path forward. So we've tapped out most of what people will use Spinnaker's out-of-the-box features for, and the stuff that's left is more of the long tail of internal tools and odd use cases that don't quite fit in the box. And so what we really want to do is give people the opportunity to contribute that, to solve their own problems, and do it fairly cheaply, because, like I said, the scope of work is very small, and a lot of people can write Java well enough to where it makes a pretty good plugin. All right, and that's about all I've got for you today. Any questions? All right, so let me repeat the question. So the question was about if and when we do break something, do we now have an obligation to fix all of that? And the answer, I think, is yes, because you really, it's very possible to develop, when you're using this kind of a setup, it's very easy to develop in a way that's either A, backward compatible, or B, you just go in and fix it. So, it's very, you're in your repo, or you just IntelliJ, it's like, find me all usages of this, replace with this, and that'll get you there pretty much all the time. So whichever way is most appropriate with the groups you're working with. Some people don't like it when other people touch their code, and that's totally fine. But so what we've set up in the GitHub repo there is a code owners file. So they'll at least get pinged, be like, hey, there's an incoming change to your code base. This is just a simple refactor. And they're like, okay, yep, looks good. So the intended use case is for everyone to be okay with that. Be like, all right, well, now, but if someone else breaks it, all right, well, now you might be a little mad, but we'll work together. It'll be okay. We'll undo it. we'll fix it. It's very easy to revert. You can revert 10 plugins by reverting once and running the publish job. So it's like, again, it's not like a thing that's going to take a long time and cause a lot of problems. It's just, it's all right there. It's like, whoop, it's out now, and we're back. Okay, great. So there's a few things that we wanted to do. So of the parts that exist in Spinnaker, stages are definitely the most popular. And the thing we write the most of internally, the stage is to do a thing, to talk to a tool, to talk to something. And that's definitely number one. However, in Orca, there's also an expression. In pipelines in Spinnaker, there are expressions. And those expressions are actually pluggable. So if you can make, and we have made several pipeline expression helpers just to accomplish various tasks. So a different form of input data coming in, slice and dice it, turn it into something that, a Helm-baked stage or a customized stage can understand. So, but you have free limited, it's totally open what sort of pipeline expression helper you can provide. For example, that's another one. And then,
so basically anything that uses the Spinnaker extension point, you can essentially write a new plugin for, and that can be tasks, stages, atomic operations, and like what Joe had just said, pipeline expressions as well.
Yep. So, boot up a Control-F Spinnaker extension point in the repo, and that'll give you the list of what currently exists. And like I said, the more extension points that there could be, the more powerful the plugin system is going to be. So, any other questions? All right, happy hour. Let's go. All right.